Okay, that previous video finished a bit uh, prematurely, but I will continue with this question, looking at the effect of temperature and the rate of an enzyme control reaction. In this video, if you've watched the first one, you'll know that you need to determine the rates or the initial rates of two different reactions, one at 37 degrees, one at 60 degrees. And so far, I had drawn the tangents to show at the initial rate, also at the initial time, so the initial rates for these two graphs. We determined that the values for the final on the final concentration of Y for both was 15 because we've extended it right to the top of the scale there. The initial concentration, sorry, the initial concentration for Y was 0. So Y1 is 0. For X1, that's the initial time, that's going to be 0. And then for X2 for 60 degrees was 3. X2 for 37 degrees was 15.5. So we need to put that all together then. So at 37 degrees, we have 15.5 minus 0. So that's Y. Sorry, no, it's not 15.5. 15 for Y2 minus 0 over 15.5 minus 0, which is, so 15 divided by, 15.5 equals 0.967. Let's say 968, round up there. Okay, for 60 degrees, the final value for Y, so Y2 was 15, 0 again, this time 3 minus 0. Even I can do that. It's 5. Okay, now this is a ratio. Wants to know the ratio of the rates 60 degrees to 37 degrees. So that means we need to make that 37 degrees 1. So to do that, we divide both by the value for 37 degrees, making 37 degrees 1, as it asked for in the question, and then 5 divided by that same value, 968, 0.968 equals 5.165, or we'll round that to 5.17 to 1. Okay, so meaning that the rate for the initial rate for the temperature at 60 degrees was 5.17 times faster than at 37 degrees. Okay, then, if you've watched the previous videos, you probably can expect there'll be an explanation question to explain the difference in the initial rate between 60 and 37 degrees. Well, at 60 degrees, there will be more kinetic energy. Okay, and therefore there will be more enzyme substrate complexes forming. Okay, as more enzyme complexes form per unit time, that means the rate will be quicker. Now, I think you could probably predict that this question might ask next why there is a plateau below the final concentration of the product mixture. of 37 degrees. So 60 plateaus below that value for a concentration compared to 37 degrees. The reason for that is at 60 degrees, the enzymes will denature. And if those enzymes denature, the active site of the enzyme will no longer be complementary to the substrate. And if the active site is no longer complementary to the substrate, the reaction will stop. Okay, so we can see that reaction stops sooner on this graph. The reaction stops sooner because of these two factors. At 60 degrees, the enzymes denature and the active site is no longer complementary. Another question that might be asked about this is why are there different concentrations of product? And the reason for that, at 60 degrees, that reaction has stopped prematurely due to the denaturation of the enzyme and the change to the shape of the active site. So not all of the substrate has been converted into product. Right, hopefully those two videos will be useful in helping you calculate the rates of reaction using a tangent. Thanks very much.